Alright, here we want to go over how to use the calculator to use an inverse normal distribution on the TI-84. It is slightly different with the StatWizard's menuing system, and there's actually two different versions of the TI-84 StatWizards here, so I'll explain both of them as I go along. Alright, so first off, just to know where the function is, if you go in the calculator, press the second and vars key, that will bring up the distributions menu. And that's where you're going to find inverse norm. Alright, and when you come down to inverse norm, highlight it and press enter, there's going to be a screen that looks like this, or if you have one of the older model 84s, you might not see the line that says tail left, center, right. Okay, so either one doesn't make any difference. I'll explain how to use both of them. It can work in the same way if you like. Let's get an example problem, and this over here will work just fine. I've got a couple for us. So the first one says that the SAT scores in a particular year were normally distributed with a mean of 977 and a standard deviation of 85. What is the lowest score you could receive and still place in the top 5% of scores? Okay, well, when we're working with any data that is normally distributed, especially if it's a word problem, a great place to always begin is to just simply draw yourself a bell curve. All this can do is just help you organize the information and get you started in the problem, because that's often where students have a stumbling block, just where to begin. Well, every normal distribution, you need to have a mean and a standard deviation to work with. So let's place those. So the mean here is 977 and the standard deviation is 85. So the mean of 977, we know that can be found right in the center of the distribution, so I can place that there. And now I'm ready to answer the question. And the question's asking me, what score is the lowest you could receive and still place in the top 5% of scores? So it's not asking for a probability. If it were asking for a probability or a percentage, I would need to use the function normal CDF. But if it's asking for what score or what percentile, these types of clues are telling us to use inverse norm. Because if I'm looking for a score, I'm looking for something relative to that mean and standard deviation. So the answer is going to be like, 1,010, for instance. It's going to be something relative to those values. It's an x value. And if you'll recall, this axis is the x-axis. So what we're looking for is some value along this x-axis that represents the top 5%. Well, the top 5%, that right there tells me that I'm looking for the value x such that the area to the right of x makes up 5% of all the data in the distribution. Now, the details about how to go into finding that go well beyond the scope of this course, which is why we're just going to use technology to do this for us. So what we do is we'll use the function inverse norm. All right, but the inputs that we're going to provide to inverse norm, we always provide an area, and then a mean, and a standard deviation. And lastly, if you have one of the more modern calculators, you can also provide what's called the tail. And I'll explain that in just a second. Now, area. If you don't have this tail option, area is assumed to always be area to the left. Okay, so it's area to the left of the value that you're interested in. If you have the tail option, you can actually change that. You can change it so that it would work with the area to the right or the area between two scores. Okay? Now, the next input, the mean and standard deviation, are just always provided. But let's see how we would do this in general. Now, if you're using the earlier model 84s that doesn't have the tail, we need the area to the left of the x value that we want. Well, this 5% is on the right side of the x value. So this area down here is the area to the left. And if 5% is to the left of that value, there's going to be 95% to the right, because it's got to add up to 100%. So this value would be 0.95, and then the mean is 977, and the standard deviation is 85. Okay, so let's go over to the calculator and get some results here. Now, if I'm over in the calculator, the inputs that it wants are areas. So we can use the 0.95 like we just came up with. Mean and standard deviation. If I was using a standard normal distribution, I would leave those with 0 and 1. But because I have a different mean and standard deviation in the problem, I'm going to go ahead and change those to what was provided. Now, if you don't have this input tail, then just assume that your input is left, because that's the basic functionality of the calculator. It will always assume the tail is to the left. And then what you have to do is, if you're given an area to the right, you have to convert it into an area to the left. So if there's 5% to the right of x, there's 95% to the left. So that's what you would have to do. If you do have this input, well, you're kind of out of an advantage here, because you can choose to just say this is an area to the right of the score, and then you don't have to worry about any conversions. You can just leave it as 0.05. Either way, you'll get the same answer. I'll go the first way, making it an area to the left, show you what the answer is. When you hit paste and then enter, it will run it, and we get 1117. All right, I'll round to the nearest integer because the mean and standard deviation are accurate to the nearest integer. So this answer here is 1117. So that makes sense with the problem, because that value is bigger than the mean, and it's fairly substantially larger in that we're looking at the top 5%, so that's going to be the very high scores here. Okay, now if I took advantage of that input with the changing the tail of the distribution, what that would look like is this. I would just simply go back into inverse norm, not worry about changing the area, just use what's given, 0.05, switch the tail to the right, and then the calculator is going to know to take this from 1 on its own. And that's all it's doing. So when we paste that, press enter, you get the same answer. Now, the thing you could run into if you're using one of the older model calculators and you don't have that option to change the tail, it's always going to operate as if you're giving area to the left. So if you don't make that change on your own, you could get the wrong answer. So that's what you need to watch out for. All right, let's try this next example. So if ACT scores in a particular year are normally distributed with a mean of 24.5 and a standard deviation of 3.8, what is the minimum score that would place a student in the 73rd percentile? Okay, so we have, again, a normally distributed set of data, and it has a mean this time of 24.5 and a standard deviation of 3.8. If this mean is in the center of the distribution, then this 73rd percentile, that's the question. So what is the minimum score that would place a student in the 73rd percentile? Well, to come up with that, here's what we need to do. So the 73rd percentile means the score that separates the lower 73% of the data from the upper, 27%? So percentiles are always area to the left. So we have this value that's going to be relative to the mean and standard deviation, because it's a score we're looking for, and we want 73% of the data to the left of that value. So what we're going to do in the calculator is use inverse norm, 0.73. We don't need to worry about conversions here at all because 73% is the area to the left. The mean is 24.5 and the standard deviation is 3.8. If you're using the newer model calculators, the last input, you would make sure you mark it as left. If you have the older models, you won't have that option, but it's going to assume that you're doing area to the left in the first place. So either way is fine. You'll get the correct answer, and let's see what that is. So inverse norm, 0.73. Whoops. A mean of 24.5 and a standard deviation of 3.8, and the tail is to the left. So when we paste that to the home screen and press enter to run it, it will give us the value 26.8, and I'm rounding that to 1 decimal place because that matches what the mean and standard deviation were. So this is 26.8, I think it was. And once again, just remember, we did not do the conversion on this number. We did not subtract it from 1 because it was already area to the left. If you have one of the older 84s and you're given area to the right, that's the only time you need to make sure you subtract that value from 1. And one thing you can do is just try and estimate what the value should be. So if you want to be in the top 5%, the answer should be bigger than the mean. And the two answers you get is 1117 and 837. This one's bigger than the mean, this one's smaller than the mean, so that kind of rules this possibility out. And that's all.